In this video, we'll demonstrate how to isolate a gross error using the fit and zero options. The current report is the default. All surveyed data points have been fitted to the design using a method known as least squares averaging. This method masks gross errors. We can use the option to drop a flange from the fit. First, we will zero flange 1 by selecting the zero option box at flange 1. Press the Apply Selections button to see the change in the visual report. The zero option does not change the report's orientation. The coordinates are translated, shifted along the grid lines to match the design coordinates at flange 1. You can now see that flange 1 has zero vector errors. This pipe spool report contains some gross errors. Look at the touch points on both flanges. There are also large vector errors at flange 2. For this demonstration, the zero option at flange 1 has been unchecked, as it will have no effect on the outcome of the next action. We uncheck the fit at flange 2. We call this dropping a flange from the fit. Dropping a flange from the fit has a significant impact, and the report now looks very different. Only flange 1's surveyed data points have been fitted to the design. Because there are only two flanges, flange 1 can be zero in all aspects, including position, orientation, and alignment. Even though flange 2 was not included in the fit, its position, orientation, and alignment are still displayed. Here is a pipe spool with more than two flanges. In this case, removing one flange produces a least squares average for those remaining. When there are more than two flanges, any combination can be excluded from the fit. It is now clear where the gross error is. The second leg of the pipe was made 50 mm too long. The report is reset to the condition where both flanges are included in the fit to demonstrate that the data has not been corrupted.